Hello students, welcome back to our channel. Now we are going to discuss about the part 3 types of chemical reactions of class 10. Okay, in that 4 types of chemical reactions we have, that is combination reactions, decomposition reactions, single displacement and double displacement. Okay, so one by one we'll try to know the symptoms of these characters. Okay, so chemical combination reactions. First one is chemical combination reactions. Name itself we can say combination means combining each other. So we can also call these reactions as a synthesis reactions. For example, A is a compound reacting with a B forming as a compound AB. Okay, so here only one product will form, but 2 reactants compulsory here. 2 reactants compulsory we have to say. 2 reactants, either it may be an element or a compound or any substance or anything, but compulsory 2 reactants should be there. 2 reactants should be involved in the chemical combination. Okay, so here for example, calcium oxide is reacting with water forming as a calcium hydroxide. So this is a solid, physical states I am mentioning, liquid, and again here is a liquid. Okay, so physical states we need to remember compulsory. Next, when you are taking the deep into the topic combination reactions, element combinations are happening. Element, like iron is there, iron is reacting with the sulfur forming as a iron sulfide compound. Okay, iron sulfide, this is a combination reaction. The same thing, metals are reacting with the sulfur forming as a sulfides. Okay, so this we can say zinc sulfide, white color will be there, sodium sulfide. Like this we can take the many reactions. For example, you take some lead nitrate crystals, lead sulfide crystals on test tube, heat it, what will happen? The black sulfide will comes to the oxygen in the form of white sulfate. Okay, so that also we can give the combination. And magnesium ribbon activity, in our previous classes we have discussed about magnesium ribbon activity, that is magnesium plus oxygen forming as a magnesium oxide. Okay, so this is a solid, gas. Okay, next again this is also solid. Okay, so here combining, oxidation reaction is happening here. Okay, so to balance this one we are doing here 2 Mg and 2 MgO. Okay, so now balanced. Same thing, sodium you take, sodium metal, any metal is reacting with oxygen forming as a respective metal oxides. Okay, so again Na2O, sodium. Okay, to balance this one we are doing here 2 Na, 4 Na. Okay, so 2 2s are 4 here, 4 Na is coming and 2 oxygens are coming. Okay, so now this is balanced. Like this we can take the element combination reactions or combining reactions also will happen here. So usually we know we have one concept that metals loses the electrons, right? So metals loses the electrons. So what happens in case of magnesium here? The monoatomic state of magnesium, oxidation number of magnesium will be 0. And here this is in the molecular form or elementary form, always the oxidation number will be 0. Okay. So here what is happening? Magnesium is increasing oxidation number here when it is coming to this +2. Okay. And here 0 to -2 oxygen is coming. Okay. So oxidation is happening in case of loss of electrons are happening here. Here loss of electrons means this one. Okay. This is oxidation. Loss of electrons we are calling as oxidation. And here gain of electrons. Okay. Decreasing oxidation number we are calling a reduction. Increasing oxidation number we are calling oxidation. Okay, so all the combination reactions we can give the examples for redox reactions. This is one thing. And the other one, when you are taking the element we have taken now, element and molecule. Next, compound molecular reactions, compound combinations. So one compound is there, this compound is reacting with another compound. For example, MgO, magnesium oxide plus water, forming it as a magnesium hydroxide. Okay, magnesium hydroxide. So no need of balancing for this. Magnesium right hand side, 1 magnesium, 2 hydrogens and 2 oxygens are there. Here also right hand side, 1 magnesium, 2 hydrogens and 2 oxygens are there. Okay, so now this equation is completely balanced like this. Compound combination reactions we can say. And next, when you are coming to the these compounds are reacting with elements. These compounds are reacting with elements. Element compound reaction. We take example. Element compound reactions. So here element I am taking it as a zinc. Okay. Compound HCl. So what will happen? So they both are combining. Here the hydrogen is replacing here. ZnCl2 plus a hydrogen gas is coming out. Okay. So like this also we can say element combination reactions, element compound combination reactions, and combining always the combination reactions we can also say it as a synthesis reactions. And here only the coefficients alone will changes. There is no involvement of the change of substances. Okay, only the balancing we need to do here. Okay, so the next one we'll discuss now. Second one, decomposition reactions. Photosynthesis reaction also we can give the example of combination, like carbon dioxide is reacting with oxygen forming as a glucose. Okay, now we will discuss about the decomposition. D means removal. D-E-D. Decomposition. Next one, decomposition reactions. So DED usually we'll say removal. So we are doing now removal of composition. Some amounts are there, some atoms are there in that compound. Those compounds we are going to break it that one. Okay. So decomposition reactions we can also call it as a analysis reactions. Analysis reactions. We are analyzing that how many number of atoms are there, and those atoms are rearranging them into form a different compounds. Okay. So here in the decomposition only one reactant should involve. Only one reactant only will involve here. Okay. In the decomposition reactions. So these decompositions we can say it as a thermal decomposition. The decomposition reactions are happening in the presence of heat. Okay. That we are calling as a decomposition. Thermal means heat. Next, electrolysis. By applying of electrolysis also we can see the decomposition is happening. Okay, thermal decompositions, and even the decomposition of like metal oxides. Decomposition of metal oxides we can take like those many examples we can give. So for example here you see mercury oxide. Mercuric oxide here on heating mercuric oxide is going to dissociate into mercury and oxygen here. And silver oxide the same, on heating silver oxide is going to decompose into silver molecule and oxygen. The same lead oxide will be dissociates into lead oxide and oxygen here. Okay, so when you are taking all these decomposition reactions, usually the decomposition reactions are happening in the presence of metal hydroxides by heat. So we will take here calcium hydroxide. Calcium hydroxide on heating. What will happen here? Calcium oxide plus water. Okay. So decomposition of metal hydroxides by water we can say. Even CuOH twice gives rise on heating. This is going to decompose into CuO plus water. Okay. So on heating what is happening? All the metal hydroxide are going to decompose into the respective metal oxide and the water. This is one thing. Okay. And heat of alkali nitrides. Heating of alkali nitrides. Alkali nitrides. For example, KNO3, potassium nitrate of this name of this compound, potassium nitrate. Potassium nitrate. On heating, what will happen here? On heating, this is going to dissociate into KNO2, potassium nitrite plus oxygen. Okay. So to balance this, we are using here 2K and here 2K. So oxygens 4 plus 2, 6 are there, and here 2 3s are 6 are there. So this equation is balanced. Okay. So even not only this, lead nitrate you take PbNO3 twice. PbNO3 twice. Some nitrates like metal nitrates only, when they are releasing on heating, what will happen here? Lead oxide will release, nitrogen dioxide will come. Okay. Lead oxide, nitrogen dioxide, and the oxygen will come. Okay. So this lead oxide will give the yellow color one, and nitrogen dioxide brown color fumes. Brown fumes it will give. Okay, brown fumes. So on decomposition of this, we'll give like this. So to balance this 2 Pb, here 2 PbO. Okay, so now this is like this. We can say the thermal decomposition reactions. And even the same thing, calcium carbonate is there on heating. Carbonates on heating, they releases again the calcium oxide plus water. Okay, so the same, calcium oxide plus carbon dioxide. Okay, so like this we can say zinc, silver carbonate you take Ag2CO3, silver carbonate. Silver carbonate will releases here as Ag plus oxygen plus carbon dioxide. So here balancing of this 2 Ag2, so 4 Ag molecules will be, so here 2 3s are 6 oxygen atoms, here 4 only is there, so here we'll write 3. Okay, and carbon was only 2 carbons are there, so we'll write here as 2 carbons. Next this is balanced now. Okay, now this is balanced. On heating, these are going to, this again, this delta symbol, it is indicating heat. So on heating, these compounds will dissociate the compounds. Okay, next we will go to the next other reactions. Other reactions we can see it. Okay, so how the other reactions are happening, decomposition reactions, that is what now we are going to see. Now we are discussing about sulfates by heat. Sulfates, zinc sulfate, on heating, zinc sulfate is going to dissociate into zinc oxide, sulfur dioxide and oxygen. See here, the sulfur, oxygen 4 atoms are there. In these 4 atoms of oxygen, it is going to dissociate in the form of 2 different compounds. One is here, when you are taking, this is a solid substance, solid, and here these 2 are the gases we can say. And here ammonium sulfate you take here. Ammonium sulfate on heating going to dissociate into aluminium oxide, Al2O3. This is in the form of amphoteric oxide, which possesses the acidic nature and the basic nature. Both will be there for this. That's why we can say amphoteric oxide and sulfur trioxide. Sulfur trioxide. Okay. Next, iron sulfate, green color will be there. This compound on heating, what will happen? It is forming in the form of brown color fumes. This is iron oxide. Okay, Fe2O3, iron oxide. And then the sulfur dioxide here it is releasing, that gives the smell of burning sulfur. Smell of burning sulfur, this will use. And sulfur trioxide. Okay, so these are the reactions of sulfates by heating. And then some reactions, reversible decomposition reactions also are there. Reversible decomposition reactions. When you are taking the reversible decomposition, for example, you take ammonium chloride. Ammonium chloride. On heating, these crystals will dissociate and again on cooling, they will recombine, right? So NH4Cl on reversible reaction, so I am mentioning like this, NH3 ammonia plus HCl. Okay, so it is going to dissociate in the form of gases, both of them. Okay, ammonium chloride is in the form of sublimable substance, right? Sublimable substance. Without the liquid state, the solid directly converts into the gaseous state. Okay, so here both ammonia and hydrochloric acid, both the gases are coming. Okay, so like reversible decomposition reactions we can say. And even another example, N2O4, dinitrogen tetroxide. Dinitrogen tetroxide on heating again, on heating and cooling. Okay, on heating and cooling, this is going to dissociate into 2NO2, nitrogen dioxide. Okay, so 2 molecules of nitrogen dioxide will come. Okay, so like this we can say the reversible decomposition reactions. And electrolytic decomposition. Electrolytic decomposition, when you are applying a water molecule, electrolytic. So electrolysis. Electrolysis. Lysis in the sense always we can say the breakdown. Okay, breakdown. And by applying of electricity, the compounds are going to break down. Okay, compounds are going to break down into C. For example, water is there, H plus, OH minus. Okay, so like this we can say H plus and OH minus. So the same water molecule ions are going to dissociate. So 2H2O, just I will write this one on electrolysis. Okay, On electrolysis, this is going to divide into 2H2 plus O2. Okay. So water molecule, when you are taking that, will dissociate into H plus ion and OH minus ion. Then this OH minus ions will give the, even NaCl you take, molten NaCl. Molten NaCl. Molten means melting. Okay. So on electrolysis, upon electrolysis, it is going to dissociate into Na plus Cl minus. Okay. So like this, by applying of electric current, this will happen like this. Okay. Or otherwise 2NaCl2, it should happen like 2Na plus Cl2 and here 2Na. Now this is balanced. Okay. That is actually in the form of dissociation of ions, we can say there. Okay. And next, some other reactions are there. We can say those are photolytic decomposition reactions. These reactions are very, very important. Photolytic decomposition reactions. Photo means light. Light. Photo in the sense light, we can say. So photolytic decomposition reactions. Photolytic. In the presence of light particles, the decomposition reactions are occurs. Okay. So photolight. Okay. How it is going to happen here? AgCl. Silver chloride is there. Okay. Silver chloride. 2AgCl on photolytic decomposition. On photolytic decomposition, this is going to dissociate into Ag plus Cl2. Okay. Ag plus Cl2 here. So silver chloride, commonly silver chloride is a white in color. Okay. White silver chloride here. This is a solid. Okay. So this solid component is going to dissociate into silver. This is a grayish white. Silver grayish white will come and chlorine gas will be there. Okay. So this is a solid and chlorine is a gas, like this. Even AgBr you take. Silver bromide. Silver bromide. Silver bromide on decomposition. Photolytic decomposition. Again this is Ag plus Br2. Okay. So this is a liquid bromine. This is actually bromine, brown in color here. Liquid bromine, brown in color. The only non-metallic element is present in the form of liquid, that is a bromine. Okay. And again here grayish white we can say here silver bromide. These two reactions are very important, and these are we are using in black and white photography. In the olden days they used to take black and white photography, silver compounds, silver with the halides, chlorine and bromine, they are halogens. Okay. So we are using in black and white photography. So most of the decomposition reactions everywhere we can say there is no oxidation and reduction here. There is no formation of redox reactions. Okay. So all the decomposition reactions does not form the redox reactions. That you can consider it. Okay. In the next video we will continue the single displacement reactions. Thank you.